Right. I think everyone joined. Boom, three more there. Right. We are now at here. One more. Okay, we'll continue. They will join. So here I got a relation. I don't know what is AC. I don't know what is A dash C. And I don't know what is A dash F. Can anybody help me in finding them? Anyone from you? What is AC equal to first? So here look at the diagram. A to C. I don't know this gap. But I know the total distance from pole to the center. Pole to the center is radius of curvature. That is capital R. That equal to, we know by the relation is to F. Are you clear? PC equal to, I know. PC is the gap between the pole to the center of curvature. Right? But here pole to the object is object distance. Sorry, in the diagram I shown wrong. I know from pole to the center is radius of curvature. Pole to the center is radius of curvature. That capital R is taken as 2F. This is. Then pole to the object, I know object distance. Pole to the object is object distance that I am taking as U. Right? Now, tell me, how do you find AC equal to? Unknown from the noun. So here, PA is equal to what? PA is equals to PC plus AC. Are you clear? Are you following? PA equal to PC plus AC. From the diagram, I am writing the relation. Right? So no one responding. I think you are in confusion. Tell me where you struck. Sricharan, okay, you are clear. Rohit. Okay, so clear everyone. Then AC equal to what I am able to write? PA minus PC. So PA is what? Pole to the object. Right? Pole to the object. That is what? Object distance. U. What is PC? R. That I am taking as 2F. So I got AC equal to U minus F. So like that I am finding here. Look at here. So this I am identifying as equation 3 because I need to replace the values of every measurement AC, A dash C, PF and A dash F. So that's why I am finding AC equal to. So AC equal to what I am writing? PA minus PC. A dash C equal to, in the same way, A dash C equal to, what is A dash C? I don't know. So I am subtracting from the noun place PC minus P A dash. Right? Then unknown values. That is what A dash F. I don't know A dash F. So I know P to A dash. So using that logic. So P to A dash, then remove the part which you don't want. So minus PF. So this I got. Right? So from this, what you are able to write? From this, what you are able to write? Here we are able to write PA is equals to pole to the object is U. What is PC equal to R? R is nothing but 2F. Then PC equal to what? 2F. PA dash equal to what? It is pole to the image distance V. Then PA dash is what? PA dash is pole to the image distance, and PF is what? Pole to the focus, right? That is focal length. So these we are substituting in the equation 3. In the equation 3. So here directly substituting or using the relation, any way you can maintain. So first of all, I am writing that AC is now PA minus PC by A dash C is what? PC minus PA dash is equal to PF is same PF, no change in that, by A dash F will be replaced by PA dash minus PF. So that is written, right? Then I know the relations here, right? I know the relations. What is PA? What is PC? So that we are replacing now. Here simply, just a second, I will clear this, or I will just move there. So below it, okay. Right. So now you are able to see clearly. What is PA? PA is equal to U, pole to the object. PA equal to U. Then PC equal to pole to the center of curvature R. That is taken as 2F. Then PA dash equal to pole to the image. That is image distance V. Then PF equal to focal length. So actually these are all unknown values. So in the problems, you will get U as something value. V is also something value, or F. All these are parameters in centimeters, right? So now we will replace these values in the above equation. PA is replaced as U and PC is replaced as 2F, or equal to 2F, by PC is already left side written with red color. Then again substituting individually. So PC is 2F, PC is 2F, and remaining PF is substituting F, and PA dash is V minus F. So this we got the relation. Then solving this. So here cross product first. What we are taking? Cross product. LHS to RHS side. Cross product or equal here in the ratio. So here U minus 2F into V minus F is equals to 2F minus V into F, or F into 2F minus V. For that, expand. So U into V, first term to the second. So U into V, U into F, then 2F into V, 2F into F. So what we'll get? U into V minus UF minus 2VF plus minus into minus here plus 2F square. That is equals to F into F, sorry, F into 2F, expanding 2F square minus F into V, FV or VF. So this I got. Then on transposing, what I want actually here left side, I'll keep UV, then remaining all are transposing towards right side. So minus will become plus on opposite side. So RHS 2F square minus VF, IST is writing. Then remaining will become minus size plus, plus size minus. So minus UF will be written as plus UF, minus 2VF written as plus 2VF, and plus 2F square it is written as minus 2F square. Everyone is clear up to here? Anything confusion? So mathematical transposing only here, nothing to worry. Just if you know the similar triangles concept and replacing of unknown values with the noun, right? If you understand these 2 points clearly, similar triangles concept, then how to replace unknown values by known values. These 2 things are important mainly, right? If you know these, this derivation is very, very easy, right? This derivation is very, very easy. Then we will continue the remaining process here. Then what to do here? Any same terms here, VF is there, VF is there. So one is with a plus and the other is with minus. Then here plus 2f square minus 2f square will be cancelled. That equal to here one is minus and the other is plus, right? So cancelled. Then here also opposite symbols are there. So difference we will take. So what the difference is remaining here? VF, right? Plus UF is remaining. Any confusion? UV equal to VF plus UF is remaining. Use your quick reaction. If there any doubt in this derivation, just ask me immediately. Otherwise, go for quick reaction. Thank you. Then what is next step here? I'm dividing this equation, right? Divide above equation by U, V, F on both sides, right? So what I can write here, I will change this partition. Right. So next I'm going for the remaining process. So UV is divided by UVF LHS side. Then RHS side also we are dividing with UVF, right? So common denominator, if you are splitting, what we can write here? Simply VF by UVF and with the same symbol UF by UVS, splitting. Then cancellation. Here UV and UV cancel, VF and VF cancel, UF and UF cancel. Then what is remaining here? LHS side 1 by V is remaining. RHS side here U is left. So 1 by U is left. Then here in the second term V is left. Sorry. Something you made mistake. Right. In the first one I made mistake. Cancellation. UV is cancelled actually. UV is cancelled, but I cancelled wrong. UV is cancelled. Then what is remained here from the first term? The remaining one is 1 by F is equal to 1 by U and 1 by V. So we can write 1 by F is equals to 1 by V plus 1 by U. In this way, we are remembering the equation. Any confusion? Ask me immediately if there is any confusion. Everyone is clear about this derivation? Using simple concept, that is similar triangles concept, and replacing unknown values by the known values. Only 2 concept. ఈ రెండు తెలిస్తే మీకు derivation పెద్ద కష్టమేమీ కాదు. Just you are imagined one situation, the object is placed beyond the center of curvature and drawing the ray diagram for that situation using R1 and R3 concept. Rays, R1 and R3 rays, you have to complete the diagram for the object beyond C. ఇక్కడ ఏమైనా కన్ఫ్యూజన్ ఉంటే మాట్లాడండి. సో ఎవరికి లేనట్టేనా సైలెంట్గా ఉన్నారంటే డెరివేషన్ ఇస్ క్లియర్. So this is about the derivation. Thank you. So Let me go for another here. Right? That is what? Sign conventions. That are what? Sign convention. For the parameters. What are actually parameters? What you are able to measure? Distances. What you are able to measure? Can anybody? What you are able to measure? In front of the mirror or behind the mirror? Parameters. Speak out. Parameters which you are able to measure in front of a concave mirror or maybe in front of a convex mirror. What you know? Look at the diagram. What you can measure? The distances. It may be in front or behind. Everyone silent.
In front of concave mirror.
I am asking both. Behind the mirror or front of the mirror. What the parameters? Name the parameters. Parameters are nothing measurable quantities. Called as parameters. Measurable quantities are called as parameters. See here, I am showing you with the arrow. Parameters shown. What you are able to measure. No one getting idea? Are you getting idea or not? See here, pole to center is what parameter? How do you name that pole to the center? PC equal to. Don't be in confusion. Pole to the center of curvature. PC equal to the distance called as radius of curvature. Pole to the focus, focal length, right? Pole to the object is object distance. Pole to the image is something I here. Pi is equals to image distance V. Then something O dash is the object. So O dash is what? Vertical length. That is exactly equal to height, right? So height of the object H naught. Then I dash. So I dash equal to what? Height of the image Hi. Are you in confusion now? What are parameters measurable here? Do you know parameters which are measurable? What's in the idea andarki? Vikrant. 7 given response. Okay. Surajita, Abhinay, 7 given. Right. So everyone is clear now. What are parameters measurable? Right. So where they are located for a concave mirror, which are fixed, irrespective to object or image, which are fixed, irrespective to the image, for example, for a concave mirror, which are located in front of the mirror. Fast, wasting the time. Focus is in front of the mirror. Center is in front of the mirror. So the focal length in front of the mirror. Radius of curvature in front of the mirror. Object always placed in front of the mirror. So U is always in front of the mirror. Height of the object is in front of the mirror and above the principal axis. According to the image, HI for a real image is below, right? For a erect image is above. Erect above, real or inverted image below. Virtual image is above. Then Image distance for a real image, front side, for a erect image or virtual image, behind. Is it clear? Because you will get the image this side for a virtual image, right? So these you have to know. For convex mirror, always characteristics are fixed. So object is in front of the mirror. So U is always in front of the mirror. Then it's a focus behind the mirror. So behind the mirror only you are measuring the focus. Center of curvature behind the mirror. So R also we can measure behind the mirror. Image also always fixed behind the mirror with fixed characteristics. So this is also we can measure behind the mirror. So everyone is clear how to identify them parameters, where they are located, right? So now we'll go for rules of sign convention, right? Here, why rules are given here? Why symbolically we are using the parameters here? Because we got a relation. What is that? Mirror's formula. Mirror's formula is what? 1 by f equal to 1 by v plus 1 by, 1 by u. 1 by f equal to 1 by v plus 1 by u. This is called as mirror's formula. To applicable for any situation, just we assumed one situation, to generalize this one or to apply all the right situations, right? We are using sign, symbolical measuring of parameters, right? What they are here? They are depending on only the direction of measurement, right? So for that, we have three rules. So the first rule is we have to start any measurement. It may be the object distance or radius of curvature or focal length or the image distance, right? Horizontally on the principal axis, what you are able to measure, that must be start from the pole, right? What they are here? Focal length, radius of curvature, object distance, image distance. We have to start from the pole. These four measurements, we are starting from the pole, right? Then look at here on the diagram, how to start. Okay, so this is your concave mirror diagram. It is also applicable for convex mirror. So if you are measuring behind the mirror, that is here, I am shown with the red color arrow. We have to start from the pole only. Don't take like this, right? Don't take like this. This is wrong measurement. Don't come to the pole. You have to go away from the pole in any measurement, right? Moving away from the pole, not towards the pole. Then right side, like this, right? Measuring direction from P. Clear, everyone? All the distances should be measured from the pole. That point I am given in the form of diagram. Only one response. Okay, right. So every point I will show you as diagram here. So first point is completed. I am going from the second for the second point. What is second point here? If you measure the distance from the pole in the direction of incident light ray, that is positive direction. In the direction of incident light ray means what? First, we have to know the incident light ray direction. Incident light ray direction always towards the concave mirror or to the reflecting surface, right? Always directed towards the mirror. So this is incident light ray direction. Everyone is clear? I shown incident ray direction on the diagram. Okay. Next, here, if you measure in the direction of incident light ray, so where is the direction of incident light ray? So this side is incident light ray direction, right? That direction, it may be in front of the mirror or behind the mirror. This direction is taken to be positive measurement. So here it is not possible in front of the mirror because all the directions are measured in this direction, right? So this is not possible in front of the mirror for a concave mirror or maybe the convex mirror. Anything, it is behind the mirror. So that's why I'm showing you the direction only behind the mirror. Is it clear, everyone, why I shown only behind the mirror in the direction of incident light ray? Because that measuring or any parameter measured in the direction of incident light ray, it is away from the pole, behind the mirror. Right? It is in front of the mirror means opposite you will get. Right? So that's why I'm taken like this. So this red color line is opposite to incident. This is in the direction. Okay. I think it now clear everyone. Just response. If there is any confusion, I will try to change. Right. So clear. So this is about the second point. If it is opposite, what to do? If it is opposite, so in the direction is what? Measuring positive direction. So if it is opposite to the direction of incident light ray, it is taken to be negative. So it is measured in front of the mirror. This direction is taken to be negative. Clear in the diagram? Are you clear? Right, very good. So now I'll go to the third point. What is third point is here? It is vertical measurements. Vertical measurements are what? Heights. Vertical measurements are what? Heights. If you measure any height, right, that must be start from the principal axis. You can move upward in direction or downward in direction, but start from the principal axis. If you measure above the principal axis, upward in direction, that we will take it as positive direction. So this is arrow direction is shown above the principal axis. So always you are placing object above the principal axis. That's why it is fixed, right? Okay, object height always positive because it is above measured, above the principal axis, right? Then one more is there, right? One more is there. That is what here, if you measure below the principal axis, downward the principal axis, it is taken to be negative. So this is downward. Wherever you get the image, inverted image is negative in direction because you will get in front of the mirror and downward. Virtual image. Virtual image, where you get virtual image? Anyone?
Behind the mirror.
Very good. Behind the mirror, what about the height of the image? Behind the mirror. Here it is, suppose image you got. How you are measuring, above or below?
Above.
Above is what?
Positive.
So everyone now clear? How to apply the rules of sign convention? For any mirror it is. For any mirror it is. Same. You can follow this for same directions or the same logic for convex mirror. Right? So logically, I will give you what are positive for concave mirror, right? What are positive for concave mirror. So U is negative, V is negative if it is real image, because in front of the mirror we can measure. H, I is negative for a real image, right? F, negative, concave mirror focal length is always measured in front of the mirror. It is always negative. The radius of curvature, negative. Then what is positive? Only one is positive. That is what? Height of the object always positive. Remaining always negative, except this image distance. If it is image distance for a virtual image, becomes positive. Behind the mirror it goes. Then HI also becomes positive if it is virtual image. So we have exemption for these only. That is only for one situation where you get virtual image. Only for one situation. What is that? Object placed between P and F. In that case only, image distance and height of the image will become positive. Otherwise, always they are negative. Except height of the object. Except height of the object. మిగతావన్నీ కూడా నెగటివే. ఏమన్నా కన్ఫ్యూజన్ వచ్చిందా లాజికల్లీ? Everyone, go for quick reaction. If there is any confusion, just immediately ask me. Right, everyone is clear. Okay, so this is about rules of sign convention. So this diagram we have to follow logically in solving the problems. అర్థమైందా? ఏ ప్రాబ్లం చేసినా గానీ లాజికల్ గా ఇది మైండ్ లో ఉండాలి, లేదు అని అంటే రఫ్ లో వేసుకోవాలి. దెన్ ఓన్లీ యూ కెన్ అప్లై ద రూల్స్ ఆఫ్ సైన్ కన్వెన్షన్ టు ఎనీ పారామీటర్. పారామీటర్ లేకుండా నువ్వు ఏదన్నా ఫార్ములా లైట్ చాప్టర్ లో యూజ్ చేస్తే అది రాంగ్. Because we derived the formula for only one situation, we are generalizing the same formula for all the situations. That's why we are following the rules of sign convention. Okay. ఎందుకు యూజ్ చేస్తాం రూల్స్ ఆఫ్ సైన్ కన్వెన్షన్? టు జనరలైజ్ ద ఫార్ములా ఫర్ ఆల్ సిచ్యువేషన్స్. ఇది మనకు మెజరింగ్ డైరెక్షన్. సో అబోవ్ ఈస్ పాజిటివ్, బిలో ఈస్ నెగటివ్. ఇన్ ఫ్రంట్ లాజికల్లీ see here, in front for any parameter, in front of the mirror negative, right? Behind the mirror any parameter positive. Above the principal axis height is positive, below the principal axis negative. ఇంకో లాజిక్ కూడా చెప్తాను నేను for the same direction. Can I say? Simple logic. One thing if you remember, for all you can apply. Right? B, behind. B, below. Right? What is below? Behind is what? Parameters. Below is what? Heights. Right? Before, below, positive. Before, below, positive. బీపీ అని గుర్తుపెట్టుకోండి, ఇది డబుల్. ఓకే, డబుల్ బీపీ. సో బి ఈస్ డబుల్, బిఫోర్ బిలో, పి ఫర్ పాజిటివ్. లాజిక్స్ కొంచెం సిల్లీగా ఉంటాయి. రైట్? బీపీ బిఫోర్ బిలో పాజిటివ్. ఓకేనా? లాజికల్ గా మెమరీ పర్పస్ before below positive, that's why I am given BP. Okay, so it is logical memory purpose, but don't write. మీకు ఏదైనా లాజిక్ చెప్తే ఏదైనా ప్రాబ్లం ఏమొస్తుంది అంటే స్టూడెంట్స్ తోటి అది రాయడానికి ట్రై చేస్తారు. అది రాయడానికి కాదు, ఓన్లీ గుర్తుపెట్టుకోవడానికి. రైట్? సో నెక్స్ట్ we have the topic is, it is magnification. Right? What is actually magnification? Magnification is nothing. It is just saying about the image is enlarged or diminished. అంటే ఏంటి? Image size is increased or decreased. Increased or decreased. మంచిగా ఉంది కదా? ఈ ప్రొనౌన్సియేషన్ ఇంక్రీజ్, డి ప్రొనౌన్సియేషన్ డిక్రీజ్. Increase enlarged, decrease diminished. Right? So here simply this information you will get by the magnification. Magnification simply a value. Magnification is what? Simply a value without any units. No units. Units ఎప్పుడు క్యాన్సిల్ అవుతాయి? ఒక లాజికల్ గా చెప్పండి నాకు, నో యూనిట్స్ ఎప్పుడు వస్తాయి? ఎనీవన్? యూనిట్స్ ఎప్పుడు క్యాన్సిల్ అయిపోతాయి? లేకుండా ఉండాలంటే క్యాన్సిల్ అయిపోవాలి. వెన్ యూ విల్ గెట్ క్యాన్సిల్డ్ యూనిట్స్? ఇఫ్ ఇట్ ఈస్ ఏ రేషియో బిట్వీన్ సిమిలర్ క్వాంటిటీస్. రైట్? ఏదైనా క్వాంటిటీ గనక మీకు యూనిట్స్ లేకుండా ఉంది అని అంటే వాట్ ఈస్ దట్ క్వాంటిటీ యాక్చువల్లీ? ఇట్ ఈస్ ఎ రేషియో బిట్వీన్ ద సిమిలర్ క్వాంటిటీ. దట్స్ ఇట్. రైట్? ఇన్ యువర్ 9th class you got about relative density, relative refractive index. They don't have units because it is a ratio between the similar quantities. అంటే ఇక్కడ మనకు magnification no units అన్నాను. ఏ రేషియో మరిది? సిమిలర్ క్వాంటిటీ రేషియో ఆర్ డిఫరెంట్ క్వాంటిటీస్ రేషియో? Similar quantities ratio it is, right? Similar quantities ratio. So it is the ratio between the similar quantities, especially it is by the హైట్స్. ఎవరికి హైట్స్ మనం మెజర్ చేసింది? ఫస్ట్ ఎవరి హైట్స్ మెజర్ చేసినాం మనం? రెండు హైట్స్ మెజర్ చేయొచ్చు. వాట్ దే ఆర్?
Object and image.
ఆబ్జెక్ట్ హైట్, ఇమేజ్ హైట్. మరి మనం ఎవరిని ఎవరితో కంపేర్ చేస్తున్నాం? కంపారిజన్ బిట్వీన్ హోమ్ అండ్ హోమ్. విత్ హోమ్? Height of the image is compared with the object, or height of the object is compared with the image?
Height of the image is object.
Very good. Always we are comparing height of the image with the height of the object. So here simply, which is compared with the other, the compared one will be taken as numerator, and with whom we are comparing, that will be taken as denominator. So this ratio is defined as magnification. Now you can define the magnification. Anyone? Definition. Magnification definition. See the expression what I am given. Magnification is equal to hi by h naught is given. So magnification is defined as the ratio between the height of image to the height of a object. Height of image to the height of a object. This is only definition. Okay. This is only definition. So mathematically, one more you will get V by U. The ratio between the image distance to the object distance. In any way you can define. In any way you can define. So this is today's class. Tomorrow I will continue how to get a relation between magnification, height of the object and height of the image to the image distance to object distance.